Hello, everyone. Welcome back to today's episode of AI in Real World, where we talk about architecting, scaling, and leading intelligent systems. In last few episodes, we talked about building and scaling AI platforms. But once these systems are in production, a new challenge begins. How do you keep them reliable, efficient, and continuously improving? And that's where today's conversation comes in. Joining us today is Shalini Sundaran, a DevOps and reliability engineer leader with deep expertise in operating AI system at scale. From her experience at Nike to KinderCare, she has been at the forefront of building resilient and high performance platforms that drive both innovation and efficiency. Thank you, Shalini, for being here today. Welcome to our podcast.
Yeah, thank you, Sheetal, for having me here. I'm excited to be here. And I've seen your podcast also on before, and like this is a great initiative. So it
Thank
is
you.
my honor to be in this, spending at least an hour here to share the insights and spread the knowledge across to give back
Definitely.
to the community.
Definitely. And I appreciate your time and your willingness to share your knowledge with the bigger community. Thank you for your kind words. So let's get into it. Yeah. Uh,
Sure.
so I want to tap into so many skills you have. So I will try to navigate through organically through whatever topic I want to cover. Feel free to add real life examples or whatever you feel necessary for my question. Okay. So let's talk about your expertise because you are into SRE role, right? So you have worked deeply across DevOps, SRE, and now AIOps. How is the nature of operation changing in the AI driven world?
Yeah, before we jump on to this, like I also wanted to introduce and also give an insight on like how my background came into this
Absolutely.
DevOps world,
Hmm.
right? So,
Sure.
I started my career like 20 years back. I
Hmm.
was a software engineer doing mostly the back-end software engineering. And like as it progressed, yes, cloud engineering and things. So, but then I was more on the software engineering side itself. So
Hmm.
I always see like, oh, operations is not my piece of thing. Like it is somebody else who would take care of it. But
Absolutely.
then like I wanted to take a step back and see it is beyond just developing the code or deploying the code and whatnot, right? Because operations have become a key thing in a software industry. So that's
Absolutely.
why like I wanted to get my hands on and see the world and eyes in a different side of the things. And that's where like I moved into SRE or the DevOps space, where I led the SRE team at Nike and currently leading the DevOps engineering team at KinderCare. To answer your question on like, okay, um, how is the nature of that operation changing? First thing itself is that mindset. So the
Hmm.
easiest way to answer this or like walk you through is like how it actually evolved, right? Like when I started in like DevOps, the big idea was very, very simple. It is
Hmm.
like stop doing things manually, like automate your deployments or infrastructure as code, ship faster. So
Yeah.
that was a huge shift at that time.
Hmm.
Then the SRE came along, right? Like it
Hmm.
was not like always existed. So then when SRE came along, so we started to add that engineering discipline on top of that, like
Hmm.
SLOs, error budgeting, reducing toils. So that gave us a real language to talk about reliability, not just like, hey, it is up or down, right? But
Hmm.
then how reliable does it actually need to be? Or like, what
Absolutely.
is that costing us?
Hmm.
So but then like over the last few years, right, like something have really changed. The
Hmm.
systems have got so complex that
Hmm.
even with like great automation or like solid SRE practices, we would still end up with like multiple engineers in the war room trying to figure out which microservice broke and whatnot.
Hmm.
So we
Hmm.
had start to like build that systems we could observe but not the system that we could easily understand.
Hmm.
That is the gap this AI ops is filling in right now. So to give a concrete real-time example,
Mhm.
probably like a few years back when we get paged at like 2 o'clock or 3 o'clock in the morning, the engineers would spend the time, at least the first few minutes would be like, oh, okay, let me first acknowledge the page, then go look into the logs, check the dashboards, try to spot that pattern.
Mhm.
But today, by the time like they open the laptop, an AI system would have grouped the related alerts, pointed to the likely root causes also maybe. So that job had shifted from more like an investigator to a decision maker types. So that is the core change here. So operations work is not disappearing at all. We have to be very, very clear with that. But it is just moving up a level, or it is at a level where it is like less time on detection but more time on triaging, right? So how then the more the questions that would come in is like, how do I design that system that fails safely when AI is wrong,
Mhm.
or how do I set the right guardrails?
Mhm.
So that's what it all comes in, where like that one thing I say a lot is AI does not fix bad foundation at all. If your DevOps pipeline is like chaotic, adding AI top of it is just going to give more like automated chaos at scale, is what I would say. The fundamental would still matter, maybe more than ever. So
Mhm.
AI ops is going to teach us how to operate along these intelligent systems. That is the shift that we are seeing here more.
I love the way you have gone through the entire process from your journey of being software engineer and what the roles, the evaluation, right? From the software engineer to DevOps, SRE, and now AIOps. That really gives a clear picture that how the responsibility has been shifted over the period of time, how the industry has evolved over the period of time. That, as you said, SRE was not a thing few years back.
Yeah,
That
yeah,
concept came new, and then people were dedicated to take care of the system doesn't go down. If they go down, we have quick resolution to make them available. So, like always we say, right? All the time, systems should be available. That zero downtime concept came into picture that our system should not get impacted. So, thank you for that detailed answer. It was very informative for me personally because I'm on the other side of the thing. I'm on the operations. I'm from the functional side, so I always wonder on the how things evolve on the other side, right? So that give me another perspective. The thing from the technical side, how do you look at it? So thank
absolutely.
you, thank you for it. So I want to go more detail into like being the you are giving the real time example. So and you have hands on based on your experience, what breaks first when you bring your traditional DevOps model and try to apply with this modern AI-driven distributed system? Because, as you said, it's still a quite a big change from the way you look at the system, right? So, what is your experience in that?
Yeah. So the first thing that breaks is the assumption that we have right now. So it is like, okay, I can understand the system by looking at it, right? Like that is the biggest thing or the first thing that breaks. So
Mm,
the traditional DevOps, right, like was built for a world where like we had only a handful of services
mm,
or like a few environments and incidents that followed like patterns.
mhm,
What we would do when there are incidents, we would go look at a dashboard, spot a red graph. Maybe 90% of the time, we will know where to go. That luxury has gone or it is going away. Let me tell you what I actually see that is breaking in production, right? The very first thing is the alerting. So in the distributed system or the modern distributed system, one bad deploy can trigger like at least 50 alerts across like 10 services in like
mm,
under 1 or 2 minutes. So the on-call engineer is not debugging the problem as the first thing. They would be busy acknowledging it.
mm,
So the old model, what we used to do is like set a threshold, get an alert.
mm,
So that completely falls apart
mhm,
because now everything is like correlated to everything else. Now it is
mm,
not a standalone thing. Everything is like you touch one place, the other thing breaks. So that is the
mm,
thing, right?
mm,
So you would end up with so much alert fatigue and people would start like even muting the
Following
channels
up.
because like, yeah, there are too many things, like I mean it is
Mm.
disturbing me, so I'm going to go. With this,
Absolutely.
what would happen is like even the real incidents would get missed.
The best.
So then the second one, first one is the alerts. So the
Mm.
next one we used to always do is like run books. So
Huh?
the traditional DevOps, right? Like we relied heavily on documented run books, meaning if X happens, do Y.
Shake this. Yeah. Huh.
So try this. Try if
Mm.
this happens, go try this one or check
Mm.
here, right? This is what it was. So that worked perfectly fine when the failures were like predictable. But
Mm.
now with the AI driven systems, you will start seeing the failures that nobody would have anticipated. Say, there could be a model drift or a GPU node that would get throttled. So
Yeah.
that will never be in a run book because nobody thought it would
If
do it, right?
problem. Mm.
So our engineers would end up improvising every time, and that knowledge would never get captured there. So that is the second one where like your run books is getting outdated.
Mm-hmm.
Then the next big thing itself is the CI/CD pipeline.
Mm.
So when we say like DevOps, right, like, yeah, we are building the CI/CD, the continuous integration and continuous deployment pipeline. So
Mm-hmm.
what we always assume is like the artifact is just the code, and it worked fine, and that is true. But now with the AI system, the artifact is just not the code. It constitutes of like code, a model, maybe a data configuration. So there are like multiple things going together, and that collectively is what we called as artifact. So what would happen is like if any of these breaks, right?
Mm.
The even the other things are perfect. Say for instance, if the model breaks, even if
Mm-hmm.
your code is perfect, the rest is going to fail. But the teams, when they ship the code, they would say like, yeah, my code passed every test. It passed performance test, unit testing, integration testing, but still the production would break
Mm-hmm.
because the model that is behind it is
Was
slightly different from the data it started and behaving differently under load. So the
mm.
DevOps pipeline would not have an idea about it because that's how like we've always thought about it is just the code. It is just the code. Now it is not only the code. Code is the core, but we still have other components added to it.
Okay.
Um, then probably one more thing and is the capacity planning where we always do a forecast pretty well, right? Like
Mm.
the traffic was very predictable. We scale like horizontally. Life is good, especially when we take like holiday seasons where we are like,
Yes.
okay, it is holiday season. Yep, let's go scale everything up. And
Mm-hmm.
now we will just wait. So that is more like a predictive scaling.
Planning.
So we'll
Mm.
scale it horizontally, keep it good. But with AI workload, we that would not behave the same way because a single LLM, right, that can cost like 100 times more than a regular API call.
Mm.
That cost can actually spike overnight also, and the finance team or the cloud engineering team would start asking questions and DevOps would not know that answer
Right.
because these are things that we never thought about,
Mm.
right? So the traditional DevOps was built for the systems that were complicated, but now with the AI driven systems they are complex, so they are two different things. So they behave in ways that emerge from interactions, not from like only one single component.
Source.
I
Mm.
think that is the truth that we have to understand on
Mm-hmm.
this whole journey. So it is not that DevOps was wrong or right. It was right for that time, but because the systems now is designed in a different way, so it doesn't exist anymore. We have to evolve towards that
Along with
new
that.
changes.
Perfect. I think you summarized. I could think of something like everything is on your fingertips now, right? Every app is talking to each other. Something similar to that.
Exactly.
Earlier, we so for to withdraw money, you have to go to the bank, give your check, ask the teller to give the cash, and then use. Like that's how we evolved. But now you don't even have to carry your card. Everything is transaction. So the
True.
industry, the way you operate itself has changed. So you have to keep up with the technology, keep up with the changes happening in the world. So there is nothing wrong or right between this. It's just a natural evolution from DevOps to AIOps. And one more thing, what I registered from the points you said, that alert fatigue, run book, completely agree. But that is because earlier, as you said, it was very strategic, very, we knew that if this is error, this is where we have to look.
Hmm.
And now it's not only larger, it's also complex and dynamic. We don't know where are the sources going to, where is the call going to come from, sources. The sources are unknown. And if new source comes in, new um, if we have to expose our data to something, some new systems, there could be more load at any given point of time. And then geographically also, we have evolved so much that everybody is, at some point of time, somebody is using your resources, right? At some point, so the downtime has, that window of being getting the downtime has reduced over the period of time. Because I remember I'm from a background. So earlier we used to take up to 2 days the downtime for doing all our cutover activities and everything. Now it's in hours. Even 1 hour extra is like, client fight with us. Why do you need another extra hours? We cannot take the system down for a couple of hours because our business will get impacted. And
Exactly.
another thing you said is capacity planning, which is more like you plan for certain events which you have, like holiday season, or if there is a product launch, then you plan for those things. But again, because the sources are unknown and it's expanding every day, you have to keep, like, it's a checkpoint you have to look at every day based on your logs and everything. That capacity can be changed, need to be changed at any point of time. That's my
Exactly.
takeaway from here.
Yeah, that is true. Like again, I think take it in a simple words, right? Like, okay, 20 years back, probably like when we all started our journey. So if you say, yeah, I know and I'm an expert in Java, yes, you are on your top of the field.
Mm-hmm.
Then like maybe 10 years later, it is like the cloud came in, right? So that is when like we started to move from like just knowing one programming language. Now we are like evolving into the cloud technology. So
Absolutely.
then it became like, okay, if you are a master in like one cloud platform, like be it AWS or Azure or like
Mm-hmm.
GCP, yes, you're pretty good. Now it is like that is gone really fast. It faded out, right? Like now, if you say like, hey, if I just know Java, you are like
Yeah,
nowhere.
yeah,
So
exactly.
that is the pace that we have to like keep like
Keep
traveling,
up with.
and that
Mm.
is how this AI is coming into play. And the AI ops is where that again, one thing that we have to keep in mind is like it is not coming and replacing anything, but
Mhm.
it is the way it is changing how we were operating with like more guardrails. So that is the key that we have to always keep in mind.
I want to dive into that exact topic, like AI, ML, the expertise you have and how it operates in the operations, like operation side AI. In nutshell, AI, ML in operations. That's where I want to go into from with my next question. So AI ops is often used as a buzzword, right? Recently, because many times, as per my experience, many times people want to do something, they call that we are going into AI option. But what actually define AI ops, and what do you mean by AI ops is actually implemented by a company?
If I had to think about it, right, in simple definition, if I wanted to explain, AI ops is just using a machine learning and automation to handle the operational decisions that
Okay.
we as humans used to do.
Hmm.
But then the speed and scale that we were not even thinking about it in the past. That is very, very simple thing.
Yeah.
It's no magic at all. It's
Hmm.
all about like taking the repetitive pattern based judgment calls, so that used to take like the engineers time, so that like they can handle the software, right? So what it actually look like in practice is, let me give you some examples.
Sure,
So
please.
before AI ops, when something broke, right, like what we used to do is like we get 40 alerts.
Hmm.
So the engineers, like I said before, they would be manually figuring out which ones actually caused these alerts. which one are just the symptoms, because they now all like connected to each other, and like, okay, all the services like upstream, downstream, everything is going to trigger the alerts.
Mm-hmm.
But then so with AI, what it is going to do is like that alert correlation. So we would build a system that would cluster related alerts together, so using the patterns from like the past incidents, and that would show one consolidated view. So it is like when the engineer comes in, like it would already have done the pre-work for it. Like here are the 40 alerts, here are the most likely the root causes, and these
Mm-hmm.
are the main services that is involved. So that is that AI ops. So nothing
Mm.
fancy, nothing like it is just that pattern recognition that is applied wherever it actually helps. So that
Okay.
alert correlation is the main thing. The
Mm-hmm.
second one is the anomaly detection on metrics.
Mm-hmm.
So in the past, what we used to do is like the static thresholds, right? Like when we say, hey, how we used to do, like we would put in as SREs or DevOps engineers, what we would do is like, okay, alert me when a CPU usage is over 80%.
Mm-hmm.
But then with AI, what we would do it differently, but same is like we would train those models on what each service normally look like hour by hour or day by day. So now we would get that same alert even now, but then that would a service is behaving differently, not only when that CPU is exactly hitting at 80%,
Okay.
but if it knows that it is not behaving the same way it is supposed to be, or it is behaving differently than what the normal is. So
Mm-hmm.
that is what is going to be that difference, that anomaly detection on the metrics. So no
Mm-hmm.
more static thresholds.
Got it.
Then the self-healing mechanisms.
Mm-hmm.
So when I say self-healing mechanism, so even now, like often what we do is like if there is a microservice that is like has a CPU failure, or like if the pod is stuck in a crash loop or something like that, we used to go restart it. If
Mm-hmm.
like a disk space is like filling up, we will go do a rotation or like cleaning. If a cache is there, so we would do a flush, right? Like I mean,
Mm-hmm.
nothing fancy in these,
Mm-hmm.
but these ones can be automatically done, like these small automations. So these can be automatically done, that self-healing mechanisms.
Okay.
And then the more critical one, or probably that would tie more from the SRE's point of view, is the RCA, the incident summarization, right? So
Mm-hmm.
whenever, okay, we have a issue, yeah, we brought in the right people, everything is done, and like we resolved, everything is good. But we wanted to learn from that mistakes, right? So
Mm-hmm.
when that actually the incident closes up, instead of one engineer spending like hours of writing up the postmortem and whatnot, the LLMs based system, what it would do is like it would draft. We don't have to start from scratch.
Mm-hmm.
Rather, it would give like a draft, meaning like the timelines. It would pull in relevant logs, metrics. So there is already a starting point where the engineering can just go and review, edit, and make it more narrative rather than starting from that scratch. I think this is where it is, right? When I put all these things together, so it is the AI ops is the layer that sits between that observability stack, your engineer, and then like that needs that human judgment. So
Mm-hmm.
all this putting together is where this AI ops is coming to me. So again, if someone asks me, do you do AI ops? My answer is definitely yes, but only because we've been very deliberate about like what decisions we have let software make, or like which ones we keep human in loop and whatnot, right?
Yeah.
So this discipline is within the boundaries, but we are not giving the entire control to the AI itself.
Yeah. Okay. Perfect. I think two things my takeaway from is the scale at which this AI helps us to find the patterns, find the anomalies, give the analysis based on this from the multiple sources, right? Maybe blog, maybe the history of your similar incidents
Mhm.
on that track, and something new has happened, and another. thing you mentioned, that it is supposed to work in such way, this way. But even if that threshold has not met, but I see something has not been in the same way. That pattern recognition again coming to that,
That
right?
anomaly detection.
Anomaly detection helps us. That's where the AI helps us. It's not that it is. Um, I don't want to use this word, but it is not going to replace the way things have happened, but it is at that scale where human brain cannot do it at that speed,
Mhm.
right? So that's where that scalability and the faster response helps us to um, get benefits from these AI ops operations.
Very
Perfect.
true.
I think you already answered my predictive failure and anomaly detection question, because that's what I was wanted to go next. But then I want to little bit twist my questions. It's still on the same line, but now uh, the, we always talk about the mean time to detect, mean time to respond. What has been changed in with this AI ops, where the AI plays a role in this? Has it been changed over the period of time because of the use of AI?
I think this one is my favorite topic, I guess, because
Okay.
the numbers are really concrete here, right? Like you can actually measure whether you're like getting better, which is like very difficult in the software, right? So MTTD is, and there are two components to it. One is the MTTD, which is the mean time to detect. So
Mm-hmm.
how long it takes for something is to know that something is gone wrong. MTTR is like, okay, how, which is mean time to resolve. It is like how long from knowing that actually fixing it, something has gone wrong, but then how long does it actually take to fix it?
Mm-hmm.
Both of them actually matters a lot, right? So
Absolutely.
what actually moved the needle here is like on the detection side, one big single change was moving from that threshold alerts to anomaly based. I think I touched on this earlier, but
Mm-hmm.
the impact on MTTD was huge on this. So we went from detecting the issues in like 8 to 12 minutes range to like under 2 minutes. For predictive cases, we were actually catching the things before they cross the user impact.
Okay.
Then the second one within the detection itself was like better signal routing, because the thing is like I said before, we know there are like multiple services that is involved. As one all call engineer, like they would not know like, okay, which service is owned by who is the owner and all that, right? That better signal routing, I think
Okay.
that was one of the key thing with MTTD. So this, like we went with like the service ownership graph and trace that, saying like, hey, this service is owned by this one. Like if this is a kind of error that happens, if this is a case, then this team owns it. So the alerts actually goes to them directly, rather than like one engineer spending time to say like, hey, which one is wrong, now I have to find out who is that person that I have to go hand it
Mm-hmm.
over and whatnot, right?
Mm-hmm.
So
Okay.
that these are the two things that changed and had shown improvement on the MTTD. Whereas on the resolution side, that thing comes in from like automated triage and like root cause suggestions.
Mm-hmm.
Then the automated remediation or the self healing for the known patterns. And probably a more critical thing is that AI assisted communication during those incidents and that post mortem acceleration, right? So
Mm-hmm.
these four things actually showed us like how we could definitely improve that MTTD and MTTR. So these were like key things which actually shown improvement on like MTTR, where we were able to like really measure and close the loop faster.
Okay. Um, I think you touch upon all the key points, but and it's very well, I'm very surprised to see how the industry has changed, and there is so much automation and system talking to each other. System is deciding that alert has to be routed to the specific owner of that services and everything. So it has a huge progress in
Yep.
that in this area.
Yep.
Um, on the flip side, though, I would like to understand when we give the autonomy to this. I mean, this is just out of curiosity, I wanted, because you touch upon that AI is finding the detecting the anomaly, it is finding the owner, alerting that owner, it's also doing the RS of that issue and then giving the feedback. How much autonomy this AI has in this whole scope of doing end-to-end things? And I believe that's where you were touching upon guardrails, where you have to. So I think that should be the key aspect of when you build these solutions, right? It's not just that you are asking them to do all these things, but you are giving the limitations that this is what you can do, this is what you cannot do, and this is where human interaction is or human interference is needed before you make any other further call on this, right?
That is true. So the key here is like data, right? Like as much as data you have, like so that you can feed the model or train the model so that like it could because I mean without having the right data, like I said, foundational, right? And when I say foundation, like data is a key. Without
Mm-hmm.
that baseline, like I mean your models are not going to act the way that you would know. Because if we just say like, hey, there is an alert or there is an issue with this service, how would it know that, oh, these are because there could be in a large scale team, right? Like where there are like 500 engineers in an
Mm-hmm.
engineering org. So it would not know like, okay, which team the service is being owned by and like where should the actual things lie on if there
Mm-hmm.
is an actual issue and all that. I think that data is the key and that is the foundational. So that is where this whole AI thing is like, is changing the way that we have been operating.
So you touch upon the scalability and you also touch upon the guardrails or principles, foundational, how important it is. So I want to take it little further.
Mhm.
And I think we talked about it a couple of times in there, like concept of zero downtime, right? Now the system cannot be taken down and you have delivered multiple projects across different regions. Zero downtime when the system at scale, what changes principally in the architecture and operationally in when you have to deliver something which cannot be taken down for when you are
Yeah.
scaling?
Okay. So if I had to tell you, I'll tell you something that is unusual. Probably you wouldn't have heard much. So when I say zero time, right? The
Mm-hmm.
zero time downtime is not really about that uptime. It is about that containment. So our goal is not to never have failures at all. That is going to be impossible at scale. The goal is to make sure that whenever the failures happen, how how should it not be the user impact, how they should not reach the user. That is the mindset
Oh,
shift we should be driving
wow.
on, like the architectural decisions itself.
Hmm.
Because I mean, to be very honest, like I mean I was in the same place where like, oh, when I say downtime, it is like it should be always up and running. So that
Hmm.
is the thing, but then that is not the actual truth. It is all about that containment.
Wow.
So
This.
so there are like few like principles that we actually put in action when we were designing this systems, where like, or when we were designing the multi-region and whatnot, right?
Mm-hmm.
So it is always like design for the failures, not for the uptime. So every component in the system, right, has to assume that everything is
It will
dependent
fail.
on, yes, it would eventually fail. Like it could
Mm-hmm.
be network timeout, it could be
Mm-hmm.
database slowdown,
Mm-hmm.
regions can go offline, it could be multiple things.
Mm-hmm.
So the systems should never get quieter under stress, but then it should not be, I mean, it should be quieter under stress but not be louder. That is the statement that I always go with.
Oh.
So again, no single region is special. So that, I
Mm.
think it sounds so obvious, right? Like
Mm.
where we there are like a lot of teams where like it quietly fails.
Mm.
What happens, and again, this is something that I have experienced in my own organization. So we say yes, we are multi-region, but then like that really one region is primary and other is just a standby. It was more
That's
like
true.
a active passive.
Mm-hmm.
So what happens is that yes, we have it ready or like it is in the cold state, But whenever there is a need, yeah, we spend some time to get it up and running. But what
Mm,
we fail to understand is like the secondary or the standby node is not like battle tested as the primary one. So
I do.
the things might break because it wouldn't have anticipated that, right? Like it is not the same scale because it is in a passive mode. So that is why we have to treat no single region is special. Then I
Absolutely.
think data, which is the really hardest part, right? Like okay, we do like do a lot of stateless services which can easily run on like multi-region. But then
Mm,
when it comes to database or like the data itself, we have to make that explicit choices about that consistency, because we need that strong consistency across the regions.
mm,
Or you have to accept that okay, it would eventually be consistent. That is where you have to like make the choices or the design choices, where like okay, I wanted this data, this particular data to be consistent all the time. It could be like payments or authorization or something. But
mm,
if it is just like personalization data or something, it can eventually be consistent but not required to be real time. So
mm,
that is where like we have to make the trade-offs to see like when we want it to be consistent and eventually be consistent.
mm,
Then the other thing is traffic management, which is very, very important. Like, I always think about it, right? Like, why should a shopper's request from, say, EMEA or Asia come all the way up to US? Say, if it was only like a US East one or US West region, right? If
mm,
I am shopping as a user in a store in EMEA or Asia, like their request comes all the way to US. So
mm.
this is
Is it
when that multi-region and active works really well, not only for the failure scenarios, but the
even for?
latency also,
Yeah.
right? Like the performance. I think that is also a key.
Oh,
And
oh.
then the deployments,
Mm.
where like most of the outages starts actually there. Like I mean, and it is a hard truth. Whenever there is an incident that is happening, right? We would say, hey, was there a deployment that happened today? Was there a deployment that happened today, right? So
Something
that
changed in the production.
exactly, yeah, that is true. So that's why like I think we have again multiple strategies there, like canary, do
Mm-hmm.
it in like one region, then like do a percentage in a region, so that like we have a fast failover and whatnot.
Mm-hmm.
Then the last one is the key, where observability, because for the season where it is like it is a thing where we always used to treat observability as like a standalone thing.
Second.
Okay, let this the system went into production today. Okay, I can have an observability. Now it is not the case. Like observability should be deployed as and when the software is changing or like getting deployed. So that is also an important thing these days. So I think
Wonderful.
with the multi-region, all of this comes into play, and like all of this plays a critical role. So I think that is my key takeaway is like skipping any of those, the zero downtime becomes like the low downtime or most of the time, which is what
Mm.
is the very different promise that we are making to the customers.
Absolutely. First of all, I like your comment that it's not zero downtime. It's how fast you react to some if something happens, how fast you contain the damage
Mm-hmm.
of that downtime. I think this is nobody have explained this concept to me so far. So thank you so much. That's a very new insight for me personally, and I like that. I'm thinking like, yeah, you cannot stop fires to be out all the time, right? There will be something wrong. All are uh, humans. We
True.
at this point of time, humans are building this system. They are making decisions. They are doing so something might break, but how quickly you react to it and how can you control the damage? That's where your automation will help you to that. How quickly you get the reports, how quickly you get the logs, how quickly you identify the root cause of it, and then take action on it.
Mm-hmm.
So that's totally different perspective. Thank you for that. And second thing, what another thing I liked about your answer is that multi-region concept. You always, and I totally agree with it. Being from finance background, I have seen that there will be always key team which will be sitting in the prominent region of that company. And you always wait, oh no, let that team come online and then we can make the decision. And that latency, even in that decision making, can cause a lot of
Mm-hmm.
losses for the company.
Yep.
That's exactly you want to avoid. Like, and coming back to your earlier answer, AI operations are not going to resolve all your operations if you're fundamentally are not clear what has to be done. In this such situation, you have to delegate the authority to the respective regions to know that they can make the calls and take the decision rather than waiting for somebody to come online and take the decision. By the time damage will be multifold. So that's another perspective you gave it to me. So I love your answer. Thank you for that. And you are giving the real life examples. So it's feeling very real. Another example what I can relate to is on the multi-region. So for our organization, we were trying to automate the so we get invoices from a vendor, right? And they come into PDF format, and there is a Alice email ID, AP for AP team, where all the PDF comes. So we were automating that. RPA will go in that mailbox, extract the PDF, identify the fields, vendor, PO number, all those things. It will come into system and post the invoice. So we always thought that everything will be in English. But when we tried for China or Israel, we found that PDF has some local characters,
Okay.
and that time it failed.
Mm-hmm.
So we sometimes we have that bias, and it's not intentional bias, but we have some biases which can cause these issues too. Again, here AI cannot help it because you never train your model to read
True.
into that thing. So that's your fundamentally you are not clear what is the objective of your goal. So I really can
Exactly.
relate to the examples you are giving. Thank you so much. Uh, so again, going into that same topic because we talked about how to take care of zero time, multi-region, and all these things. Then the next part is scale it, right? You gave the example of extreme huge number of transactions coming in the small time frame. So I think you have an example from Nike where you have 30 million personalized messages per hour, which was huge. Did it break something at that scale? And how did you handle the system? Or how did the system handle that load in that example?
Yeah. So when we take that number, right, that 30 million an hour, that sounds like a big number. And it is
Mhm.
definitely a big number. But the interesting part is not the number itself, it is that scale. So everything we assume work like everything that used to work starts to behave differently. That is the invisible or that low throughput that comes from the entire problem, right? The first thing that breaks most of the time is the database. Always. No matter what, like that is the first ever thing. So
Mhm.
it is like at low scale, right, your database is treated as just another tool. But
Mm,
then at a high scale, our database becomes a bottleneck, the
mm,
single point of failure, your biggest cost center at all at once. And why? Because there is like multiple things behind that, right? Like the connection pools max out, your write throughput might hit the wall, or the read replicas might fall behind. So even like a simple query that would run like in
Gotcha.
milliseconds or so on like low load, that
Mhm,
would take like 200 milliseconds or something, right? So which
mhm,
is definitely not in the range that we thought or we assumed that would be the scale.
mhm.
So the real fix is to stop using that database for things that it shouldn't be used in the first place. So you can actually perform the ways in a different things, right? Like if there are more reads to it, you don't have to really come into a database to read that, rather push that into a cache. Or
Okay.
if there are like multiple writes to it, you can make it in the form of queue. You don't have to do a write all the time for like each call. So I think there are like trade-offs, or like what is a durable storage, right? Like those things, that is how like the database should be treated.
Mm,
Because like I said, that is the very first thing that fails most of the time. The second one is the synchronous, because when we talk about that 30 million messages an hour, right? So
mhm,
that is roughly around like 8,000 per second on an average, which
Wow.
is like when you see there is a peak traffic, right? So
Mm-hmm.
that 8,000 might peak to like 15 to 20,000. In that cases, like it becomes very
Couple.
very difficult, it
Mm-hmm.
becomes very difficult for it. So if
Okay.
say if our pipeline is processing everything synchronously, meaning your upstream is waiting for the downstream is waiting for the database. If that is happening, right, like if one thing fails, the rest of it is all going
All.
to fail. So that is why we have to architect in a way that can be more aggressively asynchronous. So
Mm.
drop the messages in the queues so that consumer can pull it on their own pace. So that like the downstream systems, even if it like slows down, the queue would observe, and then like that failure is like propagated across.
Mm.
So
Mm.
that's why like when keeping it asynchronous would help in a lot of places. And the other one is the observability. And you would see me talk about this observability multiple times, and probably all of these discussions that we have, because that is the truth. Like
Okay.
observability is now not taken for granted. It
Mm.
is an engineering principle, it is an mandated thing, right? So your observability infrastructure becomes like bigger system than the system is actually observing. For instance, okay, we keep saying, yeah, observability is good. Like, what is observability? We keep logging. But then,
Mm-hmm.
like, if you generate like 10 logs or like 15 logs for like one request, what would happen? You're going to add more
Um,
pressure to your
so,
logs infrastructure also, right?
mm.
So just make sure that structured logs are for things that actually matters. What is key for debugging? Only
Mm.
capture that instead, because at least back in those days when we started coding, how we would say like, okay, entered this function one, exited this function two, inside this loop one. So this is how we were trained to get in. But those
Mm.
things are not going to help us. Make it sure that we make what actually matters should be debugged. And then the final thing is the cost. So the infrastructure cost, right, like that is at low scale the infrastructure is only like a line item, whereas
Mm.
like a high scale, that is a strategic concern is what I would say. A single bad decision that would make like an extra API call per message or storing too much data into memory and whatnot,
Mm.
that would cost like hundreds and thousands of our cloud bill. I think
Mm.
these are like few things that breaks very easily, where we have to like um, apply to handle all of this in like pretty consistent model for us to model a system at that scale.
Got it. So coming back to the same principle, right? When you design your solution, you have to keep these things in mind that if your scale goes high, how your
Mhm.
database will react, how many logs you have to keep in track, like for your analysis. Not everything is like there's a lot of data available, but is all the data necessary for it? And
Exactly.
based on those things, you have to do the cost benefit analysis and then make the decision that your infrastructure is capable of handling so much volume of the data. Very
True.
good.
So, like I said, like, yeah, logging is important. But then, like, if you log too much of information there, one, it is going to like um throttle your APIs itself, because like you
Mm,
are busy like logging
making
things. Like
calls.
10 or 15 logs for one call, probably not useful. And the
Mm,
second thing is like, because and when the incident actually happens, and if you have tons of logs there, how are you going to nail down where exactly is the problem? Because like there are
mm,
tons of logs, right? It is going to be nearly impossible for anybody, be it even AI, for it
yeah,
to go and dig through the tons of logs to find out what exactly is that problem. I think
I
that
think.
is what is
Mm.
like when we are designing these systems at scale, these are like very very critical things that we have to keep in mind.
Absolutely. And I think that's where that term hallucination, AI hallucinate has come up, right?
True.
If you have too
Yep.
much information, it also like lost the track where what exactly I'm
Exactly.
supposed to do. So you have to
Mm-hmm.
keep that.
True.
Perfect. So we talked about system, we talked about reliability, but another big shift which is happening right now, the way we actually work. and deliver the software, right? The methodology we have been adopting with this new AI ops thing. So my next question is on that transformation and moving towards the teams part of it.
Mhm.
And you have been through all these traditional steps and coming into work, so you are the perfect person to answer this question. So when this transformation has happened, as a like being the real witness from traditional release engineering into modern DevOps and now SRE model, what has really changed organizationally through the leadership from the process point of view? What are your uh, what are your thoughts on that?
Yeah, I think this topic is something that I care about a lot because I've lived through it from both the sides, right? Like I told you before. And
Exactly.
I'll tell you upfront, the technology part for this transformation is only, maybe I would say, like 20 to 30% of the work. The
Mm,
other 70 to 75% is the people, process, and the culture. That's the part everybody like underestimates it,
mm,
right? So when we say like we wanted to transform, right, the traditional engineering teams would look like a separate team where usually they call it as like release engineers or like build and release. So they
mm,
used to own that path to production. Developers used to write that code, throw it on the wall, and then the release team go pick it up, integrate,
do
test,
that.
deploy, and whatnot, right?
Mm-hmm.
Maybe like weekly, maybe monthly, and even like quarterly releases. So those times the releases were like big. The risk
Correct.
events were like more. So that
That's
is
true.
where like I think when something is broken in production, the question was like, whose fault is it? Now,
Mm-hmm.
how do we go fix it together, right? So
Yeah.
that model had actually worked when the software were like changing very slowly. It does
Mm-hmm.
not work when there is a need for the software where like it constantly changes or like constantly gets updated. So
Mm,
the transformation is not really about like adopting your new tools. It is more about like who owns that. The very first fundamental thing or the key thing is that ownership.
mm,
So developers own the code, ops owns the production.
mm.
It used to be like that. But a
Yeah.
new model, like developers own their services end to end, including that production. So it is,
Okay.
I think it is a common thing, right? Like you build it, you run it. That
Mm-hmm.
idea. It sounds
Mm,
probably very simple, but then that cultural change, right? I think that is the biggest thing. So that alignment is one key thing. Then the shift in the role of a platform team itself.
mm-hmm.
So what happens is like it used to be like, okay, somebody builds it, somebody goes and ships it and whatnot. No, it should
Mm,
not be that case anymore. With this transformation, what happens is like, because developers, we are saying you own that production, it means that how as release engineers or DevOps engineers or SREs, how are we going to make their lives easier so that they can take into production easily? we
exactly.
have to build we have to be that enablers for them. Like that
Mm-hmm.
is what it is, like make it as much as self-serve as possible. I think that is what is going to make that things. When we say like, oh, it is not, when we say a shift left, it is not about like, okay, I've been doing this work, now I'm going to ask you to do that work. No, that is not
Exactly.
a fair thing. But
Mm,
when I say you are going to do that work, but how easily or how self-serve it could be, I think that is that transformation. And
yeah.
then always change or like start to think about from like project to a product thinking.
Amazing.
So always like it was all project based initially. Now even like
Absolutely.
the DevOps or SRE is all product based. That is
Mm,
what like enabling other teams rather than just shipping their own work, right?
mm,
Then the metrics. So
mm,
what actually matters? So in the previous world or the traditional one, the metrics were like, oh, did we release in that date wherever we promised? No, it is not
mm.
the case anymore. It is like the famous Dora
Really.
metrics, right? Like the deployment frequency, the failure rates, mean time to recovery. So those metrics,
Mm.
the metrics is still there, but how we see those metrics is
Frequency, yes.
different.
Mm, yeah.
Exactly. And then hiring and also the skills, right? The modern DevOps is not the same as what it used to be in the traditional release engineering. So
Mm-hmm.
people now, they need to write the code and think about the systems, so
Mm-hmm.
that only then they would be able to transform or like involve into the rethinking on all of that. And then with the leadership behavior also, like it is not only about like engineers, we are saying like, hey, you have to take this shift and whatnot, right? It is also as people leaders, like how we are also enabling that, what people leader or like what the leadership does, and not just about what the leadership says, right?
Mm-hmm.
If we value that reliability, we have to reward only in like feature shipping, or that transformation would really fail. So we wanted to say like the blameless culture. But
Mm-hmm.
instead of like learning from that mistake, if we go and say like, hey, who did this, like, no, you are failing on that transformation. I think
Mm-hmm.
the leaders have a big part in that transformation, where like we have to change this in a consistent way, so that this real discipline would actually take in the form.
Perfect. So I from the personal experience, I have a little bit different perspective on this whole thing. I have also gone through the various evolution from the functional sides. As you like, there used to be functionally, they will only write function spec, they will hand it over to technical team will code it, then there will be deployment team who will deploy the code, there will be separate support team. And then from there we came to DevOps. You need to understand the code, you have to guide this, you have to give the technical specification. And now with the cursor AI and other stuff, like with the system which can code, like there is an expectation from the functional team that you can just give the prompts, get the code, probably it might be working code for you and everything. So there is a huge shift. But from my personal experience, the previous evolutions were like industry wise, like people were doing it. But this AI, I think because of the pace also, the way the AI is changing everything, it's more from the leadership. The emphasis that adopt to AI faster and faster is more from leadership. Like, and that's where I think people are sometimes lost because there is just mandate that you have to catch up with the industry. You we are lacking. People are doing so many fancy things, advanced things on AI, but our company is not doing. That's the theme I've seen for this shift from the AI ops. Did you feel that way in your experience that leadership is more aggressive on the other part without having the clear idea of what exactly you want to do, and that's where that challenge becomes more prominent, that without knowing exactly what we have to do, your foundation might not be strong, and then you will have more issues rather than having the productive output from that tool.
That is true. Again, like I said, yeah, there was a transformation, right? Like where you were just doing one programming language, and like then we moved into cloud. When this cloud, probably a decade back, when the cloud came
Mhm.
into picture, it was in a flow, right? It was not like, okay, we took like at least multi-year for it to transform, like moving from a monolithic into a cloud-based architecture
Exactly.
and whatnot. It
Yeah.
was a flow. So we were like, okay, we took time for us to like understand what it is, what it fits in, and whatnot. But with AI, it is totally different. It is like there is a spike there, or there is a peak there, right? Like where there is not even time for us to actually think about it.
Exactly.
Because I mean, the hard truth is like half of us would not even know what we wanted, but we wanted
Hmm.
to do. I
Yeah.
mean, that is where most of the failures would actually get into place, right? I think
Hmm.
that is where we have to be very, very like critical. Again, as a leader in the space, what I always tell my team is like, don't get distracted by the hype. Yes, it is a hype, but don't get distracted by the hype. I think we still
Hmm.
have to take it at a pace, because if we get it wrong, we are like introducing more risks
Yeah.
and more problems, rather than taking more in the faster pace. Yes, again, at the same time, we don't want to sit and like lay back also, right? Because if we lay back, we are like, we cannot
Going to be behind.
yeah, we
Yeah.
cannot participate in the race at all. So
Exactly.
there is like lots of noise in the space right now. Like
Hmm.
every vendor is selling AI, every conference talk is promising that autonomous everything. But
Hmm.
then we wanted to take like, okay, what, who's done this work is, right? So we wanted to take one step at a time. One step at a
Mm.
time is like very, very critical. And what fits in for your organization? A very good example is like, as a DevOps leader, I say, yes, I wanted to also implement AI on the teams that we support and whatnot. But what
Mm-hmm.
I tell my team is like, yeah, we don't have to start everything from scratch. I'm not yes, I'm going to tell
Right.
you, yes, see where AI can be applied. But I'm not going to tell like, hey, go build a agentic AI, right? Like, no, I
Mm-hmm.
don't want to do that. Rather, how we wanted to see is like what is already available. For example, we
I
are
agree.
at kinder care, we are AWS heavy.
Mm-hmm.
So we have platforms that uses like complete AWS services and all that, and we have a AWS DevOps agent.
Mm-hmm.
See if we could leverage that. That
Mm-hmm.
is still adopting that AI, right? Because
Exactly.
we already have something, then why we wanted to start from scratch?
Yeah.
So then that the time or the money or the resources that we are going to spend, it is not, we are spending in the right direction. So that is the direction that I always say, yes, we wanted to be in the race, but then like see how meaningful we can make it. Like see what is already available. If we can apply it. If not, yes, if there is a way that no, there's absolutely no way we can use the existing ones, we have to build from scratch. Yes, we have to do that. So that is why it is like that evaluation and all that goes into play before like we already like get into things. And that's probably where I think most of the organizations are like running behind AI very, very fast. We wanted to do it, but we wanted to do it very carefully. I think that
Mm.
that is what it matters a lot, I guess.
Yeah. As you correctly said, you don't have to invent the wheel every time. If somebody has invented, see if you can leverage the same and
True.
then focus on the problem which is very specific to your organization and then work on. And on top of that, also evaluate every problem on the cost benefit analysis. If I solve this problem, how much benefit I'm gonna get, and then prioritize according to that. Think that's
Exactly.
yeah.
That is
That
true. Again, I always go with a statement saying like, hey, one solution is not going to fit everybody. So again, it directly applies to me also. I used to
mm,
work in Nike before, which is like a really large scale. And like,
mm-hmm,
yes, these 30 millions per hour, 30 million requests per hour, or like these multi-region, everything would have perfectly, and it had perfectly fitted for where I came from, Nike. But I
mm,
cannot come in and like apply that for kinder care because it
simply
is a
less of
totally different organization, different business and
mm-hmm,
whatnot, right? So if I
absolutely.
come in and say like, no, we wanted to do a multi-region, it is of no use because
Mm.
like, no, it is not going to fit this ecosystem. So that is why it is like one solution is not going to fit everything. And also at the same time, what works for the organization or what works for your ecosystem, I think that is very, very critical, especially in this AI world. I think that is very important, I guess.
Perfect answer. Thank you. Thank you for that. Uh, because you touch base on the Nike one more time, I wanted to. I'm not sure if it's a kindergarten, kindercare example or Nike, but you mentioned when we were talking earlier that uh, there was a case where you reduced the manual toll by 30%. So, what
Mhm.
kind of automation initiative made that big impact?
Yeah, it was back in Nike, where again, like when we say talk about like toil is different in different languages, right? Like
Mm.
in SRE terms, toil is like what are the manual or like a repetitive or automatable work that we always keep doing it.
Okay,
Toil
okay.
on engineering is like if a machine could do, but why a human is doing instead. So you
Mm.
can see that difference of what that toil means, right?
Okay.
So we did something pretty simple. So what we tried to do is like we asked every engineer to track their toil for like 2 weeks, just a quick log. What did you do? How long did it take? What it is valuable for the engineering work or the repetitive operational work.
Okay.
So the result that we found was like really eye opening there. So
Mm-hmm.
what I try to do is like that operation that we did for like 2 weeks to say like, hey, these are the things that we've been doing. So those became like a roadmap for me. When I said roadmap, like that drove like, okay, we have been spending X amount of time on this one for all the time. And I have like a few initiatives. So always, like I said, we sorted like free frequency times, or like we picked like the top items.
Mm-hmm.
And what I try to do is like, and again, I'm telling you, this tile is not like one single project or like one single automation which reduced or which brought to this 30%. So it was like multiple smaller automations, which is where like we were able to drive to this number. The very
Okay.
first thing was that self-serve infrastructure. Like I told before, like, yeah, we used to have like a release engineering team, platform engineering team, then the
Mm.
engineering team, right?
Mm-hmm.
So the engineers used to wait for any of the infrastructure to be built, meaning if a database needs to be provisioned, or like a secrets or the IAM role has to be created, or like DNS had to be done. So all of this, what we would have is like we would have a ticket. It took like hours and days. So engineering team is going to wait for the cloud engineering team or a platform engineering team for
Mm.
them to build this infrastructure, right? So instead, what we try to do is like we built a self-service portal where the
Okay.
teams could actually request and get the things in minutes. You just put in what information it is, and like it behind the scenes, it creates the self-service infrastructure.
Oh,
Then the
wow.
second piece of it was the automated incident response.
Mm-hmm.
And I think I touched on this earlier, where I think this also deserves to be called out again as like a toil killer specifically. So what we did is like we tried to take at least like the top 20 most frequented alerts that
Mm-hmm.
were resolved in like same way. It could be like just restarting any of the instances, or like caching, cache flush, or wrote like any automation, something of that sort, right? Like basically the same incident responses, or like how we are resolving those incidents. So we
Mm.
automated those stuff. So basically, the system would detect that pattern and execute that fix. It is that self-healing mechanism. So
Mm.
that was one part of it. And the other part was, this is something very common we do all across, which is like automating like the certificates, or the secret managements, which has like, yeah, every 30 days or like every 90 days we wanted to rotate. So all of that were, I think,
Wonderful.
automated.
Okay.
Then probably the other one was the CI/CD for the deployment automation itself. So most of the teams, I would say not most, but many teams have the CI/CD. But
Mm-hmm.
then there is still like they used to have a lot of manual work there, where we used to have like pre-deployment checklist or post-deployment verification, or
Mm.
during the deployment there could be like one-time scripts that we wanted to run and all that. So
Mm-hmm.
what we did is like we built a layer that would handle all of this automatically. So the engineer would just push the changes, the system would run, roll out the changes, monitors, basically monitoring as code as well, so that like it creates the observability dashboards on Signal effects or any of the tools that we use. Then
Okay.
communicates it to the right channel, rolls back automatically if something was going wrong. So these were
Wow.
like multiple things that we tried to do. And one of
Mm.
my favorite thing was automating the audit and the compliance work. So that was something that it was like a really boring thing and a time consuming for one of my engineer on the team, where like every quarter he had to go pull the logs, generate the
Mm.
reports, prove that controls were in place and all that. And this one was particularly in our current organization,
Okay.
because we just went public, and the SOX and audits are like really, really strict about it. So
Mm, they are.
what we try to do is like we automated the evidence collection so that like it could run continuously, report and generate on demand. So
Mm.
this one was like a fire drill, literally a fire drill, like every quarter, where I stand behind them to say like, hey, did we finish this, did we finish this? But then like this one was definitely like a massive
Helpful.
quality of life improvement is what
Mm.
I would say. So this is where
Yes.
like it is right, like multiple things together is what like we did. And at Nike we built a lot of and we our communication tool was Slack. So we built like at least 300, 350 plus Slack bots there. So
Wow.
that was more like a workaround for the incidents. A very
Mm.
straightforward incident was like we used to get incidents where like, hey, I wanted to update a profile, update my address there. If
Mm.
it is not being able to do it within like the portal itself, it comes in as form of incident. What
Mm.
the production support engineers would do is like they have a handful of API calls um, in their postman. So they
Mhm.
have to first hit the first API, get the secrets, say hit the second API so that they can get a key, then use the third API to go actually update the actual profile itself. Yes, they were doing it, literally they were doing it. So this one came in as like two different problems. One is a security, where
Mm.
like you are exposing your
Your
APIs in the
personal
form
data.
of postman. Like,
Yeah,
yeah, you are giving that to every production engineer on the team. And the
exactly.
second one is like it is not a one step, it is like you are hitting three different
Three step.
APIs to do one work. So we
Mm.
built like Slack bot where like it is just through a slash command, and that would give you like, hey, if this is the profile ID, go bring the profile ID, and what are the changes that I wanted to make, it'll go and update. So this
Wow.
was just one instance, and like we have multiple instances of like Slack bots where like
Mm-hmm.
it would go even like at Nike, where there are like frequent store openings. So whenever a new store opens in retail, so there are like multiple checks that we have to do before a store can actually operate on its
Operation.
scale.
Mm-hmm.
So like maybe have to check the inventory is good, like the POS and all of that, right? So even the Slack bot was a game changer where like, hey, is this store really applicable to open it now? Like, is it all equipped with what it needs from the technology side of things
Mm.
for Nike to open a retail store? So these were
Wow.
like few things were like really eye opening. And like I said, it is just not one solution where like we drove that 30%. It is like multiple small things where we thought like, oh, this is one small thing, this is one small thing, but all put together was like really a massive thing. So yeah, that
Wow.
was a game changer for us.
I must have to say this is my longest episode, Shalini. I just checked my clock. It's been more than 1 hour, but I didn't even realize how the time flew, right? Like you've been giving real life examples and I can relate to them. So I just think like you keep talking and I will keep listening and I will just absorb all your knowledge like a sponge so that I can do the same thing. But I know time is important for both of us. So I want to go towards the conclusion of the episode, but I still want to have a couple of advices or probably a couple of directions from your experience, which can help the community who are our listeners and the people who are looking forward into these roles, right? AIOps. So going forward, like in the futuristic landscape, how close are we truly to autonomous operation, to make the operation autonomous, where system can detect, decide, and resolve issues with minimal human interaction? What's your take on that?
Okay, so I think we are in the middle is what
Okay.
I feel, right? Like the way that I think about that autonomy is like a self-driving world, right?
Mm,
Say so there are like multiple levels to it. Like level 0 through 5 is what I would differentiate. Level 0 could be fully manual, where
mm,
level 5 is like fully
fully
autonomous.
automated.
No steering wheel, no human ever needed to intervene and whatnot.
Mm,
But uh, for that, from going from that level 0 to level 5, it would take at least like few years.
mm,
So that is where I think most of us are stuck between like level 2 or 3. I think
mm,
that is not only because like the technology is not impressive. No, it is not the case. but it is like that edge cases, or like it is very hard, right? Like that first 90%, that I think that is the hard thing. So operation is exactly the same.
Mm,
The first 80% of the autonomous operation, probably we are already doing it today in production in like in multiple flavors. But the last 20%, right, I think that is where the real difficulty comes in. And
mm,
that is what is going to take at least for like next few years for us to get there to that level 5. It could be in like multiple modes, like a detection level, um, then how these modern systems can detect these anomalies, correlate each one of it and whatnot. And then is the decision level. So we are probably partially there, I guess. Like for novel problems, maybe we are already there, but for
mm,
like automated decision making, it is still a riskier. So
mm.
the systems can suggest, but then a human should always still like confirm. That is at the decision level. And at the act, so that's how like I actually split and see this autonomous thing. At action level we are carefully there, but for like reversible actions, right? So we try to do few things automatically, but we are still like having that a human in loop all the time, because like we are still not open there yet completely.
Got it.
So I think that's where like we are looking for. And like there are few things where we and when I say these things, like the first reason is the systems are changing very constantly. It is not like a slow paced anymore. The second reason is like a really long tail, right? Like
Mm-hmm.
the incidents that comes in, like that is a really long tail. And the third is like the accountability. When something goes wrong, then who's responsible? I think those are like the key things where it would take time and like few years for us to get to that level 5. I think that's what like I wanted to leave it with. And
You
probably
really,
one more
sorry.
thing that I wanted to touch on is like the trust. The accountability and trust probably both comes in hand, but
Mm,
still like when AI is like technically capable of doing something, but then that human operating system have to trust it enough
there's a,
to let it build in. I think
well
that
said
is
that.
the honest thing that I would tell.
I mean, you really touch the core of every problem, and it shows like you really have that hands-on knowledge and work like real life problem experience because it comes off from your answer, and I could relate to it. The automation part. So I will give a simple example from my experience, and this is a very recent example. So there we again, I'm from the finance side, so my all examples are always from finance side. So there is a simple thing. You always you have invoices, vendor invoices, and you have to make payments again. So if you look at it, it's there is a standard program where it picks up the open items like open invoices and make the payment. So there was a suggestion like, why don't you automate it? Like just schedule a job, system will look at all the open invoices, look at the dues, take the funds from the bank, create the JEs, and send the file to the bank. It seems to be very simple solution for it. But when we started talking to business, right, and that's where that age case you were talking about, when it comes to month end, so the practice is they do it on certain days, and every region had different day. Okay,
Mm-hmm.
that's first thing. So again, that multi-region concept came into picture. Then second thing is when it's a month end, our month end differs. Right? If your last day is on weekend or
Right.
holiday, then the earlier working days is your. Then they do before we close the period, they do day minus two that you have to do one ad hoc run, and then some payments has to be route through the legal team because they are like confidential agreements, you cannot declare those payments well. As we kept talking more and more with business, it came off like, as you said, you can solve 80% of problem, but that was never a problem statement in the long run. The problem statement was with the 20% of edge cases which needs the human interaction or human intervention to take care of those things. And it will be a long journey till we get to it. Like we reform everything, make AI the decision maker, and trust those decisions over the period of time. So I totally agree. Especially when it comes to money, right? When it comes to finance, because and personal information, both the things. In this case, you are exposing your banking information, your vendor's banking information, and there is a money involved into it. So these are the area where it will take very long time to get that trust uh, on the system, right? Thank you.
Exactly.
Like as I keep saying that I could relate your answer to my real life example. So I'm really enjoying these conversations, honestly. My last question of the episode. So, and it's just very pure, your thoughts on this. In the next 3 to 5 years, what will differentiate organizations that successfully operationalize the AI from those that struggle in production?
Yeah, this is something I always think a lot because we're already starting to see that happen, right? Like I said before, some organizations are pulling really fast, and
Hmm.
others are like spending amounts and of money on AI to see what they get it in return. The difference between these two groups are like surprisingly consistent. That's what like at least we've been seeing and whatnot.
Hmm.
But what actually separates them is like it's not what most people would guess. I think the hardest part, right? Like it is the real differentiator, the data discipline, then the operational maturity, and then
Hmm.
what I call the integration, right? Like where the real value of AI in the production is the model itself, how deeply the AI is integrated into the business workflows,
Hmm.
how the data systems or the product experiences, the operational fabric. So all of these, right? And again, a competitor can copy your model, or they cannot easily copy. So what comes in there?
Hmm.
Then is the trust engineering. I think this is going to be one of the most capability or underrated capability in like next 5 years, I guess. So it is just not about building that AI system the humans actually trust enough to use at scale and whatnot, but then it is also like a good UX or like a transparent reasoning,
Hmm.
the ability to explain the decisions, clear handoffs, and like that feedback loops and all that, right? I think that is like very critical. And
Yeah.
probably the laster and more critical one is the culture and that willingness to redesign the workflows around this AI. Just not only about like, hey, we are also doing AI, right? It's just
Hmm.
not about that. But what tells all of these together is that leadership that genuinely understand what AI can and cannot do. So I think these are the ones that would basically see how we would achieve more in like next 3 to 5 years. So I
Wonderful.
actually like the next 5 years from, or 5 years from now, the things are going to change, but it is going to be different than how we've been operating it now,
Hmm.
but in a different model. I think that is how it is. Like it is not going to complete, the incidents are still incidents, the metrics are still metrics, but how we see those incidents or how we see those metrics is going to be changing. So I think
Yeah.
that's what we have to keep in mind. And like I said, we should not be distracted by this hype. At the same time, we should still be continuing to explore what fits in, what would not fit in, and what is good, what is not good, and all that. I think we have to differentiate and take it forward.
Wonderful. So, in naturally, you are saying problem are here to stay. Is the way we are looking at the problem, the way we are solving the problem will
Mm-hmm.
change, and how adaptive you are to resolve this issue with the industry, with the clear idea what you are trying to resolve, not just jumping to all the things, is what will make you differentiate from the others.
Exactly.
Perfect.
Absolutely.
Good. So I want to end my episode with some rapid fire questions. Okay. I hope
Sure.
you are ready for that. And there are a handful. Don't
Oh yeah.
worry. My first question, one metric you always track to judge system reliability.
Golden signals.
Okay. AI ops, hype or must have? What's your one word answer?
Must have.
Okay. Biggest mistake teams make in DevOps for AI systems.
We think AI is going to come change everything.
Wonderful answer. Build or versus buy. I think you answer it, Emmanuel, but build versus buy. What is your default instinct?
It depends on where we are and like what fits in our model. So there could be build at times if it fits. If it is buy, yes, you have to buy it. So I think it depends on where we sit and like what fits your model.
As I said, you gave the explanation in our earlier discussion, so
Yeah.
thank you. Uh, Next one is one tool or practice you can't live without in SRE.
One tool or practice. Tile reduction.
Okay. In one line, what does running AI at scale really mean?
Faster, reliable, but safer also.
Perfect. Thank you so much, Shalini. You've been such a sport to be in this discussion. It was very kind and candid conversation. I really enjoyed this episode like to the fullest. Um, I hope you also enjoyed it. Happy to have you here, and I look forward to have more such conversation with you in future. Thank you for
Oh,
all your insights.
of course, Sheetal. I mean, like you said, I did not realize it is like 1.5 hour. Like I did not realize at all. And like I said, I enjoy doing this. Like, I mean, I have passion for the DevOps or the SRE practices. And these are things that I have been hands-on. And like I said, a few years back, my perspective on operations was completely different than what it is right now. So that's how like I truly built my passion around it. Yeah, thank you so much for having me here. Like I said, I really enjoyed this conversation, but and looking forward for more.
So two things before I close the episode. First of all, your passion comes off the way you talk. I mean,
Thank you.
you don't even have to mention it. It just automatically shows that the way you talk about the things, what I mean. So no doubt, I can see you are passionate. And second thing, I found a friend in you because I really enjoyed the conversation. So I'm really looking forward for more interaction with you in future. Thank you once
Absolutely.
again.
Yeah.
You have a
Thank you.
wonderful evening.